to begin with, what we're going to do is have a look at our renders. So here is our city render. And if we look at our rendered, our multi-channel EXR and look at our AOVs here, you could see that we have a velocity pass for the city. And if we look at our Zillow element, we have velocity pass rendered here as well. And generally, what these passes, these channels represents is the red channel is the motion in X, and the green channel is the motion in Y. And similarly, again, if you look at our city velocity pass, red is our motion in X, and green is our motion in Y. So that's great that we have these passes. And if we go back to RGBA, what we want to do is we want to apply this vector blur node using the velocity where these merge together. We could definitely put them individually, but for sake of speed, what we could do is just apply it where these characters have merged together. So upstream here, we've got our city with our dinosaur held out, our Zillow element held out, and we also have our Zilla with the city and debris pieces held out, and we are merging them over here. And whether you've done a disjoint over or plus, this is where we want to apply our vector blur, so we could just hit the motion blur at once on these elements. So if we grab ourselves a vector blur node and plug this in over here to our stream, to begin with, what we want to do is isolate the motion blur just to our RGBA. By default, this is set to all, which is totally fine, but what that's going to do is apply vector blur to every one of these AOVs, which we could definitely do, but for the sake of time and efficiency, if we're not going to be needing those elements motion blur downstream, then we could just forget applying vector blur to those and just isolate it to RGBA here. And the next thing you want to set is for the UV channels, you want to select your velocity pass. As you remember, with the motion blur 2D and 3D, we were using motion passes. So in this case, we're just going to use velocity. You could see we're getting motion blur applied, but something looks a little bit strange about this. And what's happening, we're getting motion blur on our background, but the Zillow element isn't getting motion blur where you would think you would be seeing it. For example, in this case, he is in the process of moving his head, so you'd expect to see some motion blur on his head. And the reason why we're not getting that is we have to take a couple steps to make sure we're passing our velocity pass properly. So if we view our disjoint over and we look at our AOVs here and we look at velocity, and if I bring gamma down and our exposure, you could see that right now all we're doing is we're just getting the velocity for our building, but for some reason we don't have Zilla's velocity coming through. And the reason why that's not coming through is in our disjoint over or plus that you've done in this merge operation, we're not carrying over, we're not merging our velocity together. So if we select velocity in the also merge section and we view this merge node now you could see that we've got the Zillow velocity coming through and merging with our city velocity. So again, to look at this again, if we set this to none, we were bypassing and not passing through the velocity for our Zilla character. So this is why we want to set this to velocity as well, so that that comes downstream. The other thing you could do is you could simply just select all here so that you can have all those AOVs come through. But if you don't need those downstream, you could just simply select velocity and make sure that that comes through. So now that we've got Zilla's motion blur velocity pass coming through and the building, we could look at our vector blur node. You're looking at our RGBA. So now if we view the vector blur node, there we go. Now you could see we're getting motion blur on his head, which is what we want. The other thing you could see is there's a little bit of an artifacting happening here, and it's something a little bit strange here. So one thing we want to do is in this premult and unpremult that we did for these elements, what we want to do is set the unpremult to all, so that all of our channels get unpremultiplied as well. And then similarly here with our premult, we want to premultiply all those AOVs again. And we'll do the same thing for our Zillow element. So we'll unpremult, instead of just RGB, we'll unpremult all. And we will premult all down here too. So this way we're unpremulting our velocity pass and premultiplying all cleanly together. And now if we look at our vector blur, we should have a little bit better result here. Now, we've got this strange situation here with this sort of a cutout quality on our Zillow here. And where that's coming from, there's a couple areas where we need to troubleshoot and sort out where that's coming from. Normally what happens is this on the vector blur node, this normalized checkbox is on. And what this normalize is doing is it's trying to normalize the tearing effect that would happen with elements overlapping one another. So this is Nuke's vector blur's approach in trying to minimize that. So if I uncheck this normalize and we look at our RGB channels, you could see that took care of that. Again, if I check it on, we have this odd behavior happening. And if I uncheck it, that is giving us some more smoother motion blur as we'd expect, which is good. Again, unchecked and checked, we're getting a better motion blur with it unchecked here. Now, one problem, if you're looking at the RGB channels, this is great. But if we look at our alpha channel, you could see we've got this cutout situation happening. And that's something that this normalize feature likes to resolve. But in our case, it was giving us a little bit of an odd behavior. So there's a couple things we could do. We can uncheck this for now, and we'll make sure to check on this soft lines. So what this does is it'll try to blur out any of the lines on the inside. So if we uncheck this, we've got this odd behavior, and if we check soft lines, it softens up these lines inside, which is good. But we still have our issue here with these overlapped areas. So one way to fix that is to apply a clamp node to our upstream here before our vector blur, and we could clamp our velocity passes just to negate any odd values inside our velocity passes. So again, I'm just going to look at our alpha channel here, and what I'm going to do is grab a clamp node, and I'll plug this in our stream here. And if I, instead of clamping all channels, if I select velocity and plug this in our stream, that took care of these holes that we were seeing from our city render. And now if we apply the same clamp to our Zillow render, that took care of that as well, which is good. So now we're getting a cleaner motion blur. Now the thing that we need to do is, with our velocity, we don't necessarily want to clamp it at 0 and 1 because this is cutting any motion that we might have, like any severe motion. And in this case, what we want to do is maybe set the maximum instead of 1 to maybe a value of 6. And we'll do the same thing for our Zillow clamp node. We'll just set that to 6 as well. And you could see we're getting more motion blur as that you'd expect. So you could take this up as high as you want. We could maybe even say like clamp it at 16. And we'll do the same thing with our city. We'll set that to 16 as well. And you could see we're getting more motion blur as you'd expect here, but it's a little bit cleaner. Now the final touch on this is, you could see by increasing this clamp on both the Zillow and our city, we're getting a bit more, we're introducing some of this edgy quality back into this. So to resolve that, now we could just go back to our vector blur node and select normalize here. And now that has cleaned up any of that little outline that we have, but we have a clean alpha channel and we're getting good motion blur. So again, but just for the sake of this example, if I disable these two clamp nodes, you could see some of these really, if I gamma this up, you could see some of this odd behavior in here because of these debris pieces having really odd velocity data in them, which is sort of a result that happens sometimes when it's rendered out. So to fix that, the simple normalize option helps it for the most part, but it doesn't fully get rid of all of this. So the best way to do it is essentially just clamp that velocity data. And now if we enable those again, you could see it's cut those values down, and we're not getting those really strange streaks happening, and we're getting good vector blur happening on our character. And we could test another frame. I will disable this and maybe go to frame 1080 85, for example. And if we reapply our vector blur, you could see we're getting good vector blur where you'd expect to see it. And maybe if we go to another frame where maybe the camera's panning as well, with the debris pieces falling, if we re-enable our vector blur, we're getting what we'd expect to see here. We're getting, not only is it just camera motion blur, but you're actually getting motion blur applied on these pieces that are falling, and everything looks good where the contacts are, and we're getting vector blur nicely on him too because he's in the process of moving as well. And now if you look at our alpha channel, it's nice and clean as well too. If you even gamma this down, we would see any potential artifacts within this. So hopefully that helps explain a little bit of how to customize, not customize, but how to clean up any issues with the vector blur node and any odd pixel values in our velocity passes. So to recap, just make sure to apply a clamp to our velocity and set a fairly high maximum for this, and just make sure the maximum, it doesn't just clamp it at 1. And then to put the final touch on it is experiment with the normalize checked on and off, and see if that's giving you any additional artifacts or if it's actually taking care of artifacts that you would be seeing in that case. The other thing you might want to do is potentially with the clamp node, set the minimum to a -1. And the reason you want to do this is because the values in the negative direction are things moving left. So if you clamp this at 0, then you're going to be clamping any values, any motion in left. So you want to set the minimum on the minimum below 0 as well too, just so that you're picking up any motion that's going to be going to the left. And I'll do the same thing here with our clamp on our Zilla character, and I'll set that to -1. This way we're getting at least any motion coming from our Z direction through there too. So there you go. Now we've got vector blur applied to our characters, I should say, and they're all playing nicely. Now, again, to recap, you could simply put a vector blur per element and merge them together, but this way it's less calculation and less processing by having multiple of these in your script. And if you merge things cleanly using the also merge feature in the merge node and making sure you're getting your velocity pass coming through, you could vector blur everything all together at once. So now we could just plug this in our stream, and if we look at our final result with everything over our background, we are getting nice motion blur on all the characters together. And we could go again to another frame like 1092, and we enable our vector blur. You could see we're getting good motion blur. Right now the camera's fairly locked off here, so we're getting mainly his movement here, but everything is getting blurred nicely together.